Welcome to this latest in our series of webinars. I'm David Galloway, and I'm delighted to serve on the board of the Centre for Intelligent Design in the UK. And I'm joined this evening by some colleagues, and we'll introduce them as we go along. But in particular, we have David Williams, who'll be moderating the Q&A session, and Dr. Alistair Noble will be participating in that as well. For those of you who've been with us in this series, we've been exploring some topics relating to the nature and direction of scientific evidence as it applies to some of the big questions we face. How can we explain the natural world? What I sometimes like to call the golfer's questions. Where have we come from? What are we here for? We've looked at everything from virology in the midst of the SARS-CoV-2 pandemic through abiogenesis with Steve Meyer and Jim Tour. We looked at orphan genes with Paul Nelson recently. And we had a great session with Dr. Gunther Beckley on the discontinuities in the fossil record. And today we'll be a little bit more specific on the fossil evidence with our topic on human origins. And I'm really delighted today to introduce our guest, Dr. Casey Luskin. Casey is live with us this evening from Seattle, where he's been living for the past couple of years. His academic background consists of a degree in law initially. He had been a California-based attorney since 2005, and then he obtained both a BS and an MS in Earth Sciences from the University of San Diego. And with that background, he's over the years assisted and defended scientists, educators, and students who've run into difficulties whilst researching or teaching about the scientific debate over the so-called neo-Darwinian synthesis, or evolution more generally, and the design hypothesis. He's been involved with the Discovery Institute in Seattle since 2005. He became research coordinator in 2011 until about 2015, when he soon after that moved to South Africa to do his doctoral studies on geology at the University of Johannesburg. And his special interest has been in paleomagnetism. And I have to tell you, I spent an hour or so with him not so long ago when he tried to enlighten me into the mysteries of his specialist subject. Casey has co-written or contributed to a number of books, including books like this, which have related to the whole question of the Dover trial. That was something which we considered last month when we looked at some of the issues relating to the design argument with David Williams. And then he's also been involved in this monster text. This is a 1,007-page book which really examines the scientific, philosophical, theological implications of theistic evolution. And Casey was responsible for chapter 14 in that big book. And it's a superb book, actually. I strongly recommend it. His chapter was on missing transitions, again on the question of human origins and the fossil record, which is our topic today. And then finally, the one I want to mention is this one. This is a book which he wrote with Doug Axe and Anne Gager. We had Doug Axe, who also led a fascinating seminar for us in November of last year. So after Casey gives his presentation, we'll have a chance for discussion in the style of a Q&A, and you can post your questions or comments in the chat section on the YouTube live stream. Do remember to subscribe to our channel. Hit the bell so that you get notification of the new events as they come out. And so at this point, let me just get ready to hand over to Casey for his presentation on hominid fossils and human origins. Casey, a virtual warm welcome to the United Kingdom. I know you were here in Scotland with us a couple of years ago to be the best man at a wedding of another famous ID proponent from these parts. So welcome back, and we're really looking forward to hearing your talk now. Thank you very much.
That's right, David. Thank you so much for that really kind introduction. And that's exactly right. It was about exactly 2 years ago that I was with you guys in the UK at a wedding for someone who is arguably a C4ID member. And I have very fond memories of meeting you there, David, and meeting many other people from the ID community in the UK who were at that wedding. It was a lot of fun. So it's great to be back with you virtually today here in Seattle, Washington. I suppose, should I share my screen here so we can get started? Okay. Okay, I'm assuming you guys can all see, oh, hold on here. Let me make sure that I'm going to be showing this on the primary monitor. Yep, okay, we're good. Okay, so thank you so much again for that introduction. This is a talk that I've given a number of times over the last year or two. It's titled Hominid Fossils and Intelligent Design. And I have been interested in this question of human origins for a number of years. It was something that actually I started researching when I was in law school, and I had already done my undergraduate and master's degree in earth sciences and taken some courses in human origins while I did those degrees. But I wrote a paper that got published in an early ID journal called Progress and Complexity Information and Design. They're sort of reviewing the hominid fossil literature. And I've stayed very much reading up on this topic for a number of years. As thank you, David, for pointing out the chapter in the Theistic Evolution book. But when I moved to South Africa a little over 5 years ago to do a PhD in geology at the University of Johannesburg, I was really looking forward to the opportunity to learn more about hominid fossils while I was there. Now, my research in geology there was not on hominid fossils, so I'm not at all trying to say that I did a PhD in this subject. But while I was living in South Africa, I had quite a few opportunities to study hominid fossils, to go to hominid fossil sites, to even get tours of hominid fossil sites by leading paleoanthropologists. And I also had an opportunity to do some sampling while I was there for paleomagnetism. So I just want to show a few photos of some things I experienced. This sort of thing that looks like a giant burial mound is actually one of the best hominid fossils in the world. It's called the Maropeng Museum at the Cradle of Humankind, just north of Johannesburg. If you ever have the opportunity to go to Johannesburg, I highly recommend going to this museum. It is truly a world-class museum, if not the best hominid fossil museum in the world. And you can find casts of famous hominid fossils, such as Homo naledi, at this fossil. And Homo naledi and a number of other hominid species, of course, were found in the region right around the Cradle of Humankind. And this is actually located only about 45 minutes north of where I lived in Johannesburg. In fact, if I went around the block and drove north on the same street for about 45 minutes, I would dead end right at this museum. These are some shots from the Sterkfontein hominid fossil site, where some famous specimens such as Mrs. Pless or Littlefoot were discovered. This here is the workshop of the famous South African medical doctor Robert Broom, who essentially founded the field of paleoanthropology in South Africa. And these are actual bones that come from this site, hominid bones that are found in this cave site there. And we had a wonderful tour of the cave and the work site there and the workshop. And I did have a couple opportunities to do some sampling while I was there. Again, I'm not actually doing hominid studies, but I was helping to sample for paleomagnetism while I was in South Africa, which was then used to date some of the hominid fossils at a Cradle of Humankind fossil site. This is Bolt's Farm. You can see me here with some large cat fossils embedded in the cave wall right next to me. And at this hominid fossil site, they do find hominid fossils, and they also found quite a few large cat fossils. So anyway, it was a lot of fun living in South Africa. I had a lot of opportunities to learn more about hominid fossils while I was there. So let's do a quick outline of where we're going to go in this talk. We're first going to discuss the evolutionary view. What is the evolutionary view of human origins? It's very important to state the views of people whom you're going to critique, or maybe you might disagree with them, and to state them accurately. So I always like to start off my presentations with a discussion of the evolutionary view. And then we'll talk about the fragmented field of paleoanthropology. In what senses is this field fragmented, and what does that say about what we know about human origins? We'll talk about the early hominins, and then we'll talk about the australopithecines, which are a group of hominids that lived about 2 to 4 million years ago. We'll talk about potential intermediate links between the ape-like australopithecines and human-like members of the genus Homo. We'll talk about the origin of the genus Homo and how our genus appears abruptly in the hominid fossil record. We'll talk briefly, if we have time, about human exceptionalism and what that is. and then we'll end with the genus Homo, all in the family. And as Dr. Galloway mentioned, I have written a couple books on this topic, or contributed to books, I should say, on this topic. I contributed a chapter to the volume Theistic Evolution, and also 2 chapters here in the book Science and Human Origins on human origins. So if you would like more references or more information, these are great resources, and pretty much nearly all of the references for what I'm talking about today can be found in these 2 books. So what is the evolutionary view of human origins? So a number of years ago, I think it was in the year 2009, I had the opportunity to testify before the Texas State Board of Education when they were contemplating how to teach evolution in public schools. And they had some scientists there who were saying, you should teach the strengths and weaknesses of Darwinian evolution in schools. And then there were other scientists there who were saying, no, you should teach only the evidence for evolution because there are no weaknesses in evolutionary theory today. And one of the scientists who was there arguing that we should teach only the evidence for evolution and that there are essentially no weaknesses to speak of was an anthropology professor at Southern Methodist University named Ronald Wetherington. And as he testified this day, here's what he said. He said, human evolution arguably has the most complete sequence of fossil succession of any mammal in the world. No gaps, no lack of transitional fossils. So when people talk about the lack of transitional fossils or gaps in the fossil record, it absolutely is not true. And it is not true specifically for our own species. And Dr. Wetherington went on to say that human origins provides a nice, clean example of what Darwin thought was a gradualistic evolutionary change. So while I was sitting there hearing Dr. Wetherington speak, I thought, well, he is articulating what I would say is a common view of human origins. This is the view that you might see in a typical biology textbook, or maybe on a National Geographic documentary or a David Attenborough special. These are the kinds of arguments you see made in the public sphere. But I also knew that when you dig deeper into the technical literature, that a different story is told, that there's actually a lot of acknowledgments in the mainstream technical scientific literature that there are major gaps in the fossil record, that our genus, the genus Homo, appears abruptly in the fossil record without direct, clear evolutionary ancestors. And so what I thought is that, look, I have no doubt that Dr. Wetherington believes what he's saying. I would never accuse him of being dishonest. I'm sure that everything he said in good faith. However, I know that there is more to the story. And what was being said that day and testified before the Texas State Board of Education was what I would call sort of a dumbed down version of human evolutionary origins, not an actual scientifically rigorous approach that really looks at what's in the technical literature and what it says. So after this, I really decided to dig deeper into the technical literature and find out what it says. So within a couple of years, I co-wrote that book, Science and Human Origins. And this is a standard phylogeny of human origins based upon what is typically believed to be true in the evolutionary community. It starts off around maybe 5 to 8 million years ago with what we call the early hominins, species like Sahelanthropus chidensis, Aurorantugensis, or Ardipithecus ramidus, which are thought to be some of the earliest hominid fossils that branched off from the line that led to modern chimps and were possibly some of the earliest upright walking or bipedal species that stood at sort of the dawn of the human lineage. And then it's not known exactly how, when, or where, but somehow they evolved into what we call the australopithecines. And while these early hominin fossils are very fragmented, we only have a few specimens, and there's not very much known about them. With the australopithecines, we actually have many specimens, some of which are very complete. And they lived from about 2 to 4 or 4.5 million years ago. And we have a very good idea of who they were. And they are then said to have evolved into our genus Homo. And there are certain species which are said to have been intermediate between the australopithecines. Australopithecines tend to be very ape-like, and the major members of the genus Homo tend to be very human-like. And some of these species that are sometimes cited as intermediate links between the ape-like australopithecines and our genus Homo would be Homo habilis, and we'll talk about some others as we go through this presentation. So our species, of course, is Homo sapiens, and some other major members of the genus Homo that you've probably heard of before would be Homo erectus or Homo neanderthalensis. And we're thought to be very closely related to them. So this is sort of the standard hominin phylogeny that you often see. So what we're going to see today in this talk is that the fossil record does not document the evolution of humans from ape-like precursors. And also hominid fossils generally fit into two, or what you might say, three categories. We have ape-like species and human-like species with a large unbridged gap between them, as well as some what I would call unique species that don't bridge those gaps. So before we get into the talk too much, I want to do a brief point of information on terminology. What do we mean when we say the term hominid or hominin? Well, unfortunately, these terms are used inconsistently, even in the technical literature. Sometimes the word hominid is used to refer to any member of family Hominidae, which is a family which includes human beings, the chimps, and all the other great apes, gorillas, orangutans, and so forth. So that is one way to define a hominid. But the term hominid is also sometimes used to refer to any member of this branch which branched off from the supposed most recent common ancestor that we share with chimps, and then any member of this branch which then includes humans and ultimately led to human beings, or our species Homo sapiens. And in that sense of a hominid, we often hear the word hominin. And the word hominid or hominin is, those two terms are often used interchangeably. So I'm going to use, and this is also used this way in the technical literature. So when I say the words hominid or hominin during this talk, I'm going to use them in this sense in which the terms are used in the technical literature to refer to any member of the genus Homo or this branch which branched off from the most recent common ancestor we share with chimps and led to human beings. So let's now talk about the fragmented field of paleoanthropology. Well, the field of paleoanthropology is fragmented in three senses. First of all, the fossils themselves are fragmented. Then the record is fragmented in space and time. And then finally, the field itself is fragmented. What do I mean by this? Well, first off, the fossils themselves are fragmented. Stephen Jay Gould, a very famous paleontologist, once said that most hominid fossils, even though they serve as a basis for endless speculation and elaborate storytelling, are fragments of jaws and scraps of skulls. There was a paper in the journal Science a number of years ago that said that the primary scientific evidence is a pitifully small array of bones from which to construct man's evolutionary history. One anthropologist has compared the task to that of reconstructing the plot of War and Peace with 13 randomly selected pages. Conflicts tend to last longer because it is so difficult to find evidence to send a theory packing. I find that quote very interesting. But what they're basically saying is that the fossils are so fragmented that we often know very little about what they actually show. So to give a sense of how difficult it is to reconstruct the hominid fossil record, I took the cover of War and Peace here, and I am showing it on the left with just 13 small squares. Now imagine trying to reconstruct this whole cover of this book with just these 13 squares. That would be next to impossible. But yet that is something like what we see in the hominid fossil record. Fossils tend to be very few and far between, and they're very fragmented. So the fossils themselves are fragmented, and the record is fragmented. This is a quote from another Harvard scientist, Richard Lewontin. He said, "When we consider the remote past, before the origin of the actual species Homo sapiens, we are faced with a fragmentary and disconnected fossil record. Despite the excited and optimistic claims that have been made by some paleontologists, no fossil hominid species can be established as our direct ancestor." So the record is fragmented. The field is also fragmented. I love this quote. This is a quote from a PBS Nova producer who was doing a documentary on Neanderthals. And he said that each Neanderthal expert thought that the last one I talked to was an idiot, if not an actual Neanderthal. So the record is also, the field is also fragmented. And this harkens back to that quote we saw from that article in the journal Science that said that it's often very difficult to refute various models or various theories in paleoanthropology because the record is so sparse. There's a lot of infighting. And when you read books by famous paleoanthropologists, they will regale you with tales of, paleoanthropologists refusing to share bones or evidence with other research teams because they're very possessive and very jealously guarding their research findings. And there's a lot of sort of personal acrimony and infighting that takes place in this field. Now, I want to say that some of these quotes that you just saw are a little bit dated. The quote from Stephen Jay Gould in the journal Science is from around the year 1980. And they're talking about the sparseness of the fossil record and the fragmented nature of the bones. Well, I would say that even though those quotes are somewhat dated, they still hold true today. by and large, the hominid fossil record is highly fragmented, and most fossils we find are merely bone fragments. In fact, this is a quote from the year 2001 by Henry Gee, a senior editor at the journal Nature. He says, fossil evidence of human evolutionary history is fragmentary and open to various interpretations. And my point is that, okay, that's fine. So if you want to hold an evolutionary view, that's fine. I don't have a problem with that. But are we going to say that a non-evolutionary view of human origins is one of these various interpretations which is permitted when the data is so sparse, and especially when our genus Homo appears abruptly? We'll see that people have referred to the appearance of our genus as a Big Bang theory of human evolution. So why is it not acceptable in the scientific community or in education to talk about a non-evolutionary model or to challenge these evolutionary views of human origins? So what about the interpretation that humans did not evolve from ape-like precursors? Is that allowed? I would say it should be. So let's talk about the early hominins. One of the first hominins that was discovered in this millennium was a species named Aurorantugensis, or Millennium Man. And the New York Times put out this headline, "Fossils may be earliest human link." Well, what exactly was found? Well, it was literally just a few bone scraps. Now, in this case, they actually did find part of a femur. And some people were saying that maybe this fossil is one of the first bipedal upright walking species that stood at the dawn of the human lineage. But a few years later, we found a Yale University press book said that all in all, there's currently precious little evidence bearing on how Auroran moved. So what we see in Auroran is my first example of a very common rhetorical theme in hominid fossils, and that is that when they are first discovered, the media will immediately present and tout these fossils to the world as if they are the latest human ancestor, the latest, they'll use the term quote unquote missing link, and the latest piece of evidence that humans did evolve from ape-like creatures. But then after this sort of initial media hype, you wait a few months and you see that cooler heads prevail, and technical papers are then published in the scientific literature, and you can see a very different story usually being told that very frequently challenges the initial hype that the species was a common ancestor. So this is a good example of that. We'll see other examples of that. In 2009, there was a species named Ardipithecus ramidus that was published in the journal Science. And again, we saw the media hyping this fossil as the latest human ancestor. Discovery Channel called it Ardi, oldest human ancestor unveiled. Associated Press, world's oldest human-linked skeleton found. And the journal Science called it the breakthrough of the year. Could give you many more examples of this. Tim White, one of the lead Ardi researchers from UC Berkeley, said that Ardi is the quote-unquote Rosetta Stone for understanding bipedalism. And of course, bipedalism means upright walking. So is Ardi really a great example of a bipedal upright walking species? Well, it turns out that a lot of artificial reconstruction went into Ardi species. Initially, Time magazine reported that some portions of Ardi's skeleton were found crushed nearly to smithereens and needed extensive digital reconstruction. So when we're talking about bones like the pelvis, which was initially reported to look like an Irish stew, how can we know that some bias has not gone into that reconstruction when you're doing what we call digital reconstruction? How can we know that these are really being reconstructed accurately if these bones initially look like an Irish stew? The pelvis is a very important bone for determining whether a species walked upright. And just a few slight changes in the curvature and various contours of the bone could change whether this indicates an upright walking species or a quadruped that walked on all four. So I would say we have good reasons to be skeptical. Other literature reported that Ardi initially looked like roadkill, squished, chalky, distorted, crushed to smithereens. So I would say that there are, again, good reasons to be skeptical of these reconstructions of these fossils. And of course, a few months later or a few years later, after Ardi was initially published, cooler heads did prevail, and we saw different views being promoted in the hominid fossil record. An article in the journal Science said that all of the Ardipithecus ramidus bipedal characters cited also serve the mechanical requisites of quadrupedality, in other words, walking on all fours like an ape. Bernard Wood, a leading paleoanthropologist, wrote in the journal Nature that he said the claim that Ardipithecus ramidus was a facultative terrestrial biped is vitiated because it is based on highly speculative inferences about the presence of lumbar lordosis and on relatively few features of the pelvis and foot. So over time, cooler heads prevailed. The technical literature then called into question that already was a bipedal species and even whether it was a human ancestor. And one of the original scientists that was quoted said that he regarded the hype around Artie to have been overblown. And interestingly, there was an article that just came out a couple months ago in the journal Science Advances, which said that Artie had the hands of a tree climber and of a knuckle walker. Basically, it had a chimp-like mode of locomotion. So again, as time goes on, we see that these initial claims are often refuted or disputed in the technical literature. So a last example here is Sahelanthropus chidensis, which was published initially in the journal Nature. It was called a human ancestor, but another article in the journal Nature then said that the species was linked with gorillas or chimpanzees to the exclusion of hominids and that Sahelanthropus was an ape. But as late as 2014, it was still being called a human ancestor. Bill Nye, the science guy, I don't know if you guys had him in the UK, but when I was a kid, he was always on TV. Bill Nye has turned out to be sort of a very harsh materialist evolutionist, but he wrote a book in 2014 that said that fossil hunters found a whole range of human ancestors, including Sahelanthropus chidensis, and every one of these is what he calls a no longer missing link. Well, guess what? As of November 2020, there was an article published in the Journal of Human Evolution that found that Sahelanthropus is from a quadruped with a chimp-like body plan, and a paleoanthropologist was quoted saying it's more similar to a chimp than to any other hominin. And I think that sort of puts to rest claims that Sahelanthropus was a human ancestor that walked upright. Okay, so now that we talked about the early hominins, let's talk about the australopithecines. As I said, in contrast to the early hominins, we actually do know quite about the australopithecines. Their name literally means southern ape. They lived about 1.9 to 4.5 million years ago. They had a brain and a body about the size of a chimpanzee. And the most complete and most famous known australopithecine specimen is Lucy, or Australopithecus afarensis. Now, australopithecines, especially Lucy, are often described as a chimp-sized species that had the ability to walk upright, much like modern humans. But there are many australopithecine traits that are ape-like and are not human-like. That includes the arms, the chest, the striding gait, the shoulders, the abdomen, the inner ear canals, the developmental patterns, the toes, the teeth, the hand bones, and the brain size. So there are many features of australopithecines which are very distinct from human beings. And some of these are directly relevant to whether they walked upright. In fact, although Lucy has been called a small-brained bipedal ape, it is small-brained, but the bipedality is controversial. Nature found that the hand bones of Lucy show that she knuckle walked, as chimps and gorillas do. So obviously that's very different from our mode of locomotion. There's also evidence that Lucy spent a lot of time in trees. New Scientist said everything about her skeleton, from fingertips to toes, suggests several traits that would be very suitable for climbing in trees. The American Journal of Physical Anthropology, much like we saw with Artie's pelvis, found that Lucy's pelvis was initially badly crushed with distortion and cracking. And an article in the Journal of Human Evolution said that there was error in the reconstruction of Lucy's pelvis, creating a very human-like sacral plane. So we can't always say that these reconstructions are accurate and showing that these species walked in a bipedal manner. So it's important to be skeptical of some of these claims. The Journal of Human Evolution went on to say that prevailing views of Lucy's posture are almost impossible to reconcile, and that to resolve these differences, more anatomical fossil evidence is needed. The available data at present are open to widely different interpretations. And Bernard Wood said, Australopithecines are often wrongly thought to have had a mosaic of modern human and modern ape features, or worse, regarded as a group of failed humans. Australopithecines were neither of these. So I think there are good reasons to be skeptical that Lucy was sort of this upright walking human ancestor. In fact, if we ask the question of, do we have evidence that the Australopithecines evolved into our genus Homo? You can see in this diagram, on the left, we have an early member of the genus Homo, and on the right, we have Lucy. And an article in the Journal of Molecular Biology and Evolution said that no gradual series of changes in earlier Australopithecine populations clearly leads to the species early Homo, and no Australopithecine species is obviously transitional. So clearly we have a problem with the fossil record. We don't have Australopithecine species that are transitional into early Homo. University College London anthropologist Leslie Aiello said that the australopithecines are like apes and the Homo group are like humans. Something major occurred when Homo evolved, and it wasn't just in the brain. So let's talk about these potential intermediate links that are supposed to be bridging the gap between the ape-like australopithecines and our human-like members of the genus Homo. Well, one of the most famous classically cited fossils as an intermediate that bridges that gap is Homo habilis. However, there have been quite a few studies that have found that habilis does not serve as a very good link. The journal Nature said that the habilis skull represents an unlikely intermediate between the morphology seen in australopithecines and Homo erectus, which was a very early form of Homo that is actually in many respects very similar to modern humans. The Journal of Human Evolution said it is difficult to accept an evolutionary sequence in which Homo habilis, with less human-like locomotor adaptations, is intermediate between Australopithecus and fully bipedal Homo erectus. Ian Tattersall, a famous paleoanthropologist, calls Homo habilis a wastebasket taxon, little more than a convenient recipient for a motley assortment of hominin fossils. So he's not sure if this species actually even exists. So it turns out that a major review was published looking at the morphology of Homo habilis a few years ago. This was originally published in the journal Science in 1999, and then it was published in a Springer Verlag book in 2015 by two leading paleoanthropologists. And what they found is that across the board, Homo habilis has Australopithecine-like traits: body size, body shape, locomotion, jaws and teeth, development, and brain size. And essentially, it should not even be classified within Homo, that it really is more like an ape-like member of the Australopithecines. So if Homo habilis is really Australopithecus habilis, then without it, we are left with a major discontinuity between the genus Homo and the genus Australopithecus, from which we supposedly evolved. So over the last few years, we've seen a few fossils that have been proposed as replacements for Homo habilis, as potential fossils to bridge this gap between the ape-like Australopithecines and the human-like members of the genus Homo. And in fact, just before I moved to South Africa in 2015, there was a major fossil find reported from the cradle of humankind in South Africa called Homo naledi. Now, this was a spectacular find. It's one of the largest troves of fossils ever discovered. CNN called Homo naledi a new species of human ancestor discovered in South Africa. The Daily Mail: scientists discover new skull of human ancestor, Homo naledi. PBS: trove of fossils from a long-lost human ancestor. And it was a trove. There was many fossils, many bones that were found. But is it really a human ancestor? Well, it turns out that Homo naledi had an australopith-sized brain, long curved fingers and toes that indicate it was a tree climber, and overall its morphology is unique. In fact, its discoverer Lee Berger said the species is quite different from anything else we have seen. So initially it was proposed to be a potential link between the ape-like Australopithecines and human-like Homo. And initially, Homo naledi's promoters suggested that it lived 2 to 3 million years ago during this time period when Homo supposedly evolved. But that date was not from any geological analysis. It came strictly from evolutionary considerations, because this is when they wanted that fossil to have lived in order for it to serve as this intermediate transitional form. However, in 2017, a paper was published that gave a geological age for these fossils, and it was dated to only 1/10 of the age which it was claimed to have in order to be a link. It was dated to only 250,000 to about 300,000 years old, far too young to be a human ancestor. So it does not make a very good link at all. It can't be a human ancestor. It's about 10 times too young to be a human ancestor. Now, it's interesting that in the year 2010, many of the same scientists who discovered and promoted Homo naledi as a link were promoting a different ancestor du jour. And that was Australopithecus sediba. And again, lead discoverer Lee Berger said they make a very good candidate ancestor. Well, it turns out that Australopithecus sediba is also too young to be a human ancestor. It postdates the genus Homo by about 800,000 years. Now, what's interesting is that in 2018, an article in the Journal of South African Science, the species was also found in the cradle of humankind, said that, look, the fact that it's too young to be a human ancestor is not that big a deal. We can ignore the order of species in the fossil record. We can ignore geochronology and just say, well, maybe the species, we have this specimen, but maybe it actually lived much earlier than when we found it. Maybe they have what we call a ghost lineage. And evolutionary scientists do this all the time. Whenever the fossil record does not fit with their preferred evolutionary history, they will just invent what they call ghost lineages, which are basically periods of time for which they claim a fossil existed because of evolutionary considerations, but for which we have zero fossil evidence. So that's what they did here. Well, finally, in 2019, a study decided to tackle this tactic that evolutionary scientists use of just inventing ghost lineages to resolve any fossil geochronology problem and to allow them to essentially ignore geochronology. And what this paper did in the journal Science Advances is they plotted up a histogram of all the time differences between supposed ancestor and descendant species in the hominid fossil record. And what they found is that given that Homo or Australopithecus sediba is about 800,000 years younger than the genus Homo, they plotted a bell curve and fit it to this data set and asked what is the likelihood that it would be ancestral to the genus Homo given other ancestor-descendant relationships in the hominid fossil record. And they found that the likelihood of it being ancestral to the genus Homo is less than 0.001. So very, very unlikely that this species is our human ancestor. Now, what about Homo naledi, where the time differential is closer to 2 to 2.5 million years? Well, here, I don't even know. It's way on the right tail of the bell curve. So the likelihood that Homo naledi could be ancestral to human beings, given that it's about 2 to 2.5 years too young to be ancestral to the genus Homo, I think it's safe to say that it's certainly statistically unlikely, impossible, or highly unlikely, implausible, we should say, that it would be ancestral to the genus Homo. So there's another problem, not just geochronology causes a problem for sediba being our ancestor, but so does cladistics. And that is because Australopithecus sediba, if it is in fact our ancestor, supposedly evolved into Homo naledi. But if that's true, then key traits are evolving backwards because Australopithecus sediba had a pelvis, teeth, and hands that are more human-like than they are in Homo naledi. So they can't be human ancestors in the same evolutionary lineage, even though the same scientists were suggesting both are our ancestors. It just does not make sense because key traits are evolving in a less human-like direction if Australopithecus sediba is ancestral to Homo, which includes Homo naledi. So a major paper that reported sediba said that the ancestry of Homo and its relation to earlier Australopithecines remains unresolved. And if that's true, that it's not our ancestor, then we're left with what I call retroactive confessions of ignorance, that they confess that we don't know the origin of the genus Homo and its relationship to the Australopithecines, but we know now that this species cannot be our ancestor. So we're left with some statements that were made by leading paleoanthropologists during the time that sediba was first reported. They said that the origins of the genus Homo remain as murky as ever. That's Daniel Lieberman from Harvard, or Donald Johanson said the transition to Homo continues to be almost totally confusing. So let's talk about the origin of our genus Homo, what it looks like in the fossil record. Well, the technical literature reports an explosion, rapid increase, or punctuated change, and an approximate doubling of brain size at the appearance of Homo around 2 million years ago. A study of pelvises in Australopithecines and Homo found very rapid evolution corresponding to the emergence of the genus Homo. We basically see this abrupt appearance of Homo-like organisms, Homo-like species in the fossil record. In fact, an article in Molecular Biology and Evolution said that Homo erectus or Homo ergaster, basically some of the earliest members of the genus Homo, were significantly and dramatically different from Australopithecines in virtually every element of its skeleton and every remnant of its behavior. The changes are sudden. No Australopithecine species is obviously transitional. They call it a radical transformation, or in other words, a genetic revolution. So something radical happened here with the origin of the genus Homo that is not documented by the fossil record. They call it a genetic revolution. Basically, a totally new kind of organism appears abruptly without clear evolutionary precursors. In fact, because of this evidence, it was proposed that this is a quote unquote Big Bang theory of human evolution. So I find this very interesting. So in light of this kind of evidence, 3 Harvard paleoanthropologists discuss what they call the bad news and the good news about the transition from Australopithecus to Homo. And here's what they say. The transition from Australopithecus to Homo was undoubtedly one of the most critical in its magnitude and consequences. As with many key evolutionary events, there is both good news and bad news. First, the bad news is that many details of this transition are obscure because of the paucity of the fossil records, and archaeological records. So what is the good news? Okay, the bad news is that the details of this transition are obscure. But what is the good news? Well, the good news is they say that although we lack many details about exactly how, when, and where the transition from Australopithecus to Homo occurred, we have sufficient data from before and after the transition to make some inferences about the overall nature of key changes that did occur. So in other words, what they're saying is that the fossil record provides the ape-like Australopithecines before and human-like Homo after the supposed transition, but not actual fossils documenting a transition between them. And in the absence of intermediates, we're left with inferences of a transition based strictly upon the assumption of evolution, not actual fossils that are transitional. In fact, the great evolutionary biologist Ernst Mayr, one of the greatest evolutionary scientists of the 20th century, wrote in 2004 that the earliest fossils of Homo are separated from Australopithecus by a large unbridged gap. How can we explain this seeming saltation? Well, not having any fossils that can serve as missing links, we have to fall back on the time-honored method of historical science, the construction of a historical narrative. In fact, and this problem was not just for humans, that we see human beings with the genus Homo appearing abruptly in the fossil record. A major 2015 review of hominid fossils said that the evolutionary sequence for the majority of hominid lineages is unknown. Most hominin taxa, particularly early hominins, have no obvious ancestors, and in most cases, ancestor-descendant sequences, fossil time series, cannot be reliably constructed. So let's talk very briefly about human exceptionalism, what that means, and then we'll close out the presentation. Human exceptionalism is a view holding that the human race has unique and unparalleled moral, intellectual, and creative abilities. So what are some obviously exceptional human qualities? Well, we have complex language, we have complex tools, fire, clothing, abstract reasoning, mathematics, music, poetry, religion, moral reasoning. Bioethicist Wesley J. Smith says, we are unquestionably a unique species, the only species of even contemplating ethical issues and assuming responsibilities. We uniquely are capable of apprehending the difference between right and wrong, good and evil, proper and improper conduct. So we have many unique traits as human beings that are not found in the animal kingdom. In fact, MIT professor and linguist Noam Chomsky says that human language appears to be a unique phenomenon without significant analog in the animal world. There is no reason to suppose that the gaps are bridgeable. So do we understand the origin of human language? If any of you have read this book, Sapiens, that came out a few years ago by Yuval Noah Harari, this book was everywhere in bookstores. He said that we're not sure how human language evolved. He says that it was due to, quote unquote, accidental mutations that were, quote unquote, pure chance. So we don't know exactly how human language evolved. We don't know why this cognitive revolution happened or what those mutations were or how they changed our brains, but we're sure it all happened due to, quote unquote, pure chance. So I don't find these evolutionary explanations of human language to be very compelling. Now, Harari says that the ability to speak about fictions is the most unique feature of human languages. Fiction has enabled us not merely to imagine things, but to do so collectively. We can weave common myths such as the biblical creation story. Such myths give sapiens the unprecedented ability to cooperate flexibly in large numbers. And I would say that Harari is undoubtedly correct that shared beliefs, what he calls myths, do foster cooperation, and that does help us in our survival. But this is an observation, not an explanation for why we have these shared myths and shared beliefs that tie a society together and allow us to cooperate and survive. And I would argue that perhaps shared myths, which foster friendship, fellowship, and cooperation among humans, did not result from, quote unquote, pure chance evolution, as he calls it, but reflect the intended state of human society as it was intended by a benevolent designer. And that large-scale cooperation might be a designed consequence for a society with widely shared religious or other beliefs, not accidental evolutionary byproducts. So I would argue that his arguments do not explain why humans have this ability to cooperate through shared beliefs and shared myths. That might reflect a designed and intended state of human society. So I would say that human beings have many traits which go far above and beyond what is necessary for humans to evolve, to survive and reproduce on the African savanna a couple million years ago. Think of some of the great figures in human history: Michelangelo, Albert Einstein, or Oskar Schindler. These three people did amazing things, which do not seem to show things that would be required if all that's required for evolution is for us to survive and reproduce on the African savanna. Michelangelo painting the Sistine Chapel. Albert Einstein coming up with these amazing theories of relativity and the origin of the universe. Oskar Schindler risking his life to save the Jews, members of who were not even members of his tribe. We see these people as representing sort of the pinnacle of what human beings can do, and yet none of this should be required, should be necessary for us to survive and reproduce on the African savanna. All we have to be able to do is to hunt, find food, and find a mate. These go far beyond what is necessary for humans to evolve by natural selection, these abilities. So I would argue that human life is about much more than mere survival and reproduction. So the next time someone tries to break down the differences between humans and apes, remind them that it's humans who write scientific papers studying apes and not the other way around. So let's close this up real quick here, talking about the genus Homo and how the members of the genus Homo are very similar, or what I call all in the family. Well, in contrast to the australopithecines, the major members of Homo, such as Homo erectus and Neanderthals, are very similar to modern humans. In fact, they're so similar to us that some have classified Erectus and Neanderthalensis as members of our own species, Homo sapiens. If you look at the skull shapes of Homo erectus, Neanderthals, and Homo sapiens, they're very similar. There are some small differences, but generally speaking, they're very similar. And below the neck, these species are almost identical. If you look at this diagram, it shows the average skull sizes of Erectus, Neanderthals, and Homo sapiens, as well as various ape-like species like the australopithecines or chimps. And it turns out that Neanderthals actually had an average skull size that is slightly larger than modern humans. And even though Homo erectus had a skull size that is slightly smaller than modern humans, it's still within the range of modern human genetic variation. So if we could take hominid fossils if we wanted to, and we could line them up from small to big and show a very gradual increase in skull size. But does that necessarily document the gradual evolution of intelligence? Well, it turns out that total brain volume weakly correlates with intelligence. Brain size accounts for between 9 and 16% of the overall variability in general intelligence. That's Christoph Koch, who's a president of the Allen Institute for Brain Science here in Seattle. So brain size is not a very good indicator of development. Case in point, the brain size of the Russian novelist Ivan Turgenev was about 2 kilograms, but the brain size of the French novelist Anatole France was about 1 kilogram. So even Turgenev's brain was literally twice the size of Anatole France, and yet they were both celebrated novelists of the 19th and in one of the early 20th century. So I think that this is good evidence for why brain size is not crucial for determining intelligence. Internal brain organization is much more complex and important for determining intelligence than is the sole dimension of brain size. So even if we could line up skulls from large to small, that does not show that human intelligence and human behavior evolved gradually. In fact, Homo erectus has shown signs of potentially being much more intelligent than we're often told. Some paleoanthropologists have found evidence of erectus fossils on isolated islands. And what they've argued is that in order for these erectus specimens, these erectus individuals, to end up on these islands, land bridges are not options in these cases. They had to arrive by boat. And in order to arrive by boat, that required a very high level of intelligence and even language. In fact, one linguist says that sailing demonstrates a level of cognitive development rivaling even that of modern humans. The erectus accomplishment of paddling across one of the strongest ocean currents in the world required not only cooperation, but also corrections, instructions, and commands. few detailed instructions or corrections can be given without language. So there is some evidence that erectus may have been much more intelligent than we often think they were. As for Neanderthals, although they do have some structural body shape differences, they have a bun at the back of their head. They have a slightly stockier build than modern humans and slightly thicker brow ridges. They still show very similar behavior potentially to us. Washington University paleoanthropologist Eric Krinkhaus said, they may have had heavier brows or broader noses or stockier builds, but behaviorally, socially, and reproductively, they were all just people. Another archaeologist said that Neanderthals were using technology as advanced as that of contemporary anatomically modern humans, and were using symbolism in much the same way. And so contrary to popular perceptions and arguments from some evolutionists, Neanderthals do not show that humans are descended from primitive and or ape-like species. They were highly similar to modern humans. In fact, there are some fossils that show mosaics between modern humans and Neanderthals, or some people have argued that human beings today, especially in Europe, have Neanderthal DNA. So what's really the difference between us and them? In fact, a few years ago, some paleoanthropologists put together an exhibit showing Neanderthal specimens. It was a team of French and Israeli scientists. And it was immediately widely discussed on the internet that this Neanderthal they reconstructed looked a lot like Chuck Norris. And of course, this led to all kinds of Chuck Norris jokes. If Chuck Norris was a Neanderthal, he'd still be smarter, stronger, and more advanced than you. There is no theory of evolution, just a list of animals that Chuck Norris allowed to live, or Chuck Norris once kicked a horse and a giraffe. That's how giraffes evolved, or horse in the chin, sorry. And that's how giraffes evolved. And so, of course, we can continue on with Chuck Norris jokes, but the reality is, and this is from a paleoanthropologist, Sigrid Hartwig Chair, the differences between these human-like members of the genus Homo can be explained as microevolutionary effects of size variation, climatic stress, genetic drift, and differential expression of common genes. So the different members of the genus Homo are very similar, and I would call their differences to be the result of small-scale microevolutionary changes. On the other hand, the fact that we see the genus Homo appearing abruptly in the fossil record is very consistent with intelligent design. Stephen Meyer and others wrote that intelligent design provides a sufficient causal explanation for the origin of large amounts of information. The intelligent design of a blueprint often precedes the assembly of parts in accordance with a blueprint or a preconceived plan. When we see something appearing abruptly, fully formed in the fossil record according to a blueprint, that is good evidence of intelligent design, and that is exactly what we see with the origin of our genus Homo, the abrupt appearance of our Homo body plan without clear direct evolutionary precursors. So some quick take-home points. Number one, hominid fossils generally fit into two categories: ape-like species and human-like species with a large unbridged gap between them, as well as some unique species that don't really fit in anywhere else. This morphological discontinuity reflects a genetic revolution, which has led others to cite a Big Bang theory of human evolution. The genus Homo appears abruptly in the fossil record in a manner that challenges standard Darwinian explanations of the origin of our species. And a Big Bang model requires the rapid origin of new genetic information and is best explained by design. And I'd like to think that Chuck Norris would approve of this. In fact, in the official Chuck Norris handbook, or fact book rather, he said, "I believe in microevolution, genetic mutations that provide small variations in different species in the animal kingdom. But I don't believe those micromutations lead to macroevolution, large genetic jumps that turn one animal into another, such as apes into humans." I would have to say is well said, Chuck. Not bad for a Neanderthal. So thank you very much. If you have any questions, I'd be happy to chat with you guys for a while and discuss this further. So thank you guys very much.
Good, Casey. Well, thank you. So it's over to David Williams now, and David will take us through and moderate the question session. I see a few questions have appeared on the YouTube chat, and no doubt there'll be others from myself and perhaps Alistair, and others may come in as well. David, thank you.
Yeah, and I repeat that. Thanks ever so much, Casey. That was a fascinating talk. Can I get you to unshare your screen? And excellent. And then we can see you. Okay. I'm going to start with a slightly tongue-in-cheek question, which is this: I'll just use one of many examples, Australopithecus. How do you, and how long did it take you to be able to pronounce those so quickly and without tripping up over your tongue on repeated occasions?
Oh man, that is a good question. I think everybody struggles with that. The hardest one is lumbar lordosis, which has to do with the curvature of the bottom of your spine. Try saying that 10 times fast and you'll definitely get tripped up. So yeah, some of these names are pretty technical. I've given this talk a number of times now, so I guess it just go and practice in front of the mirror and you too will be able to say it fast.
Okay. Well, look, we've had some questions come in. I had some questions beforehand as well. And just a reminder to anyone watching, please type away and I'll try to get all questions to Casey. Can I start with this one, please, Casey? You've mentioned timescales as to certain dates you said didn't fit in with the evolutionary timescale. Are you talking about geology there, geologic timescales, or are you talking about genetic timescales?
Yeah, those are geological time scales. We don't have any DNA from these earlier hominid fossils, nor do we have DNA from the australopithecines. There is some Neanderthal DNA and some DNA from some very comparatively recent members of the genus Homo. We don't have a Homo erectus DNA either, though. So all of this data comes from geological dating methods. It's not from genetic timescales. And so when you see these ages are not from, say, evolutionary interpretations of how long ago we think they lived based upon this evolutionary argument or that evolutionary argument. It's based upon what they believe to be the correct geological ages of this, which I don't really have a problem with those ages. So yeah.
Okay. Next question is this. What would be your answer as to how the sudden changes in direction or direction of hominin, I think that is, happened?
So I think I touched on this a little bit at the end, but when we see a new body plan, a new type of organism, or sort of a new group of organisms appearing rapidly and abruptly in the fossil record, I think that is best explained by intelligent design. And I say that because, let's say that you're a car manufacturer and you want to introduce a new car into the market, okay? You design the car, you come up with its form, you make it work properly. It's an integrated whole with all these different parts and complexity, and then you introduce it into the market to be sold. And that is the way designers operate. They tend to introduce things fully formed, fully functional, all at once. And we see that with the genus Homo. It appears quite abruptly in the fossil record without clear direct evolutionary precursors, fully formed. I mean, below the neck, Homo erectus, which is basically, one of the first specimens of human beings, the first, complete specimens that we have, of the genus Homo, not humans, of the genus Homo. It's one of the earliest fossils we have. Below the neck, it's almost identical to modern humans. Even above the neck, it's still very similar. Like I said, although the average erectus skull size is smaller than modern humans, it's still within the range of modern human genetic variation. And so what I would say is that we see this abrupt appearance of a new type of organism, and then we see stasis over time. It doesn't really change very much. That to me is a good indicator of the way an intelligent agent works. Introducing something into the world fully formed without necessarily, connecting it to direct ancestors, and then it sort of just remains the same as long as it's there.
Okay, well, that ties in with the next question, which is this. Do you think that since some of the genes are the same, we do have a common ancestor that got external input of information, the question says brackets, through God, close brackets, in other words, that changed primates?
So that common ancestor was not an ape-like species. I want to make that really clear. I do believe that we are probably related to Neanderthals and Homo erectus. I think you can make a very good case for that. But those species are human-like. They're very human-like, okay? So the species that we are very different from would be the genus Australopithecus, some of the early hominins. We're very different from those. So if we're going to say that we're related to those other species, I would like to see fossil evidence of that in the fossil record. I would like to see sort of this Darwinian gradual evolutionary lineage, which is what Professor Wetherington cited that when I quoted him at the very beginning of the talk. So if we are related to these ape-like species like the Australopithecines or the early hominids, then the nature of that relationship is not standard Darwinian evolutionary ancestry, okay? Because we don't see this sort of neo-Darwinian process of gradual change via random mutational natural selection. We see an abrupt change, okay? So in that sense, those sort of discontinuities, those abrupt changes in the fossil record, I don't think, for me personally, I don't think that that's very consistent with the claim that we share a common ancestor with those groups. So I tend to be a skeptic of common ancestry for that reason. I recognize that there are some folks in the ID movement who support common ancestry, and even when they do support common ancestry, they will often take a non-Darwinian version of common ancestry where they're saying that, you know, maybe God did tweak, or the designer did tweak the DNA so that it gave birth to something that was very different. I suppose that that's possible. But for me, I want to see evidence before I believe that. And I think from a fossil perspective, there's not good evidence of human and, say, chimpanzee common ancestry, or that we share a common ancestor with the australopithecines.
Now, let's just dive into that a little bit. What would amount, in your view, to sufficient evidence? Because if one starts with a gap that you've talked about, if a fossil comes that's halfway between the two, some people would say all you've got now is two gaps. So where does the fossil evidence have to be before you would be satisfied that amounts to sufficient evidence?
Sure. So this is a common rejoinder from an evolutionary view that, like, if you know what creationists, they'll call us creationists, will always say that, you know, if you're missing this fossil, then there's a gap, and you're missing that, and then I find one that fills that gap, and now you have two gaps. No. That is a total misrepresentation of what I'm saying, okay? Ernst Mayr, one of the leading architects of the neo-Darwinian synthesis in the 20th century, said that the difference between Australopithecus and the genus Homo is, in his words, a large unbridged gap, okay? A large unbridged gap, all right? So we're not talking about something that's very small. We're talking about a large unbridged gap. Well, why is it a large unbridged gap? It's a large unbridged gap because the Australopithecines, so I'm stumbling over my own words now. The Australopithecines are very ape-like, okay? So we have two groups. We have ape-like species and we have human-like species in the fossil record, okay? So if we do share a common ancestor, then there should be species that can bridge that gap. That's the claim that's being made, okay? That's a fair test of that claim. And what we don't see in the fossil record, in my opinion at least, are species that bridge that gap between the ape-like Australopithecines and the human-like members of the genus Homo. So I would say what I would like to see is not leading paleoanthropologists from Harvard or around the world calling this a large unbridged gap, or saying that we don't have any information about how these ape-like Australopithecines evolved in the genus Homo, or not saying that we have a Big Bang model of the genus Homo. Those are not the kinds of words that are consistent with a Darwinian view, a Darwinian model of gradual unbroken chain, which is what Professor Wetherington said. So I would say that this standard evolutionary model is not supported by the fossil evidence. We can play this game where, okay, we find a fossil and then now we have two. I'm not playing that game. I'm saying that there are two different groups, and I want to see if there's fossils that are bridging that group in order to establish their ancestry, their common ancestry. And I don't see those fossils. That's why I'm a skeptic.
Now, you've, and I think you're quoting obviously Ernst Mayr about the large unbridged gap. What's the answer to the question? Exactly how large is that, quote, large unbridged gap? And are you able to give an idea from, is it based on anatomical differences, or how could you give some practical examples to demonstrate exactly how big that gap is?
Sure. Well, it's large enough for one of the leading evolutionary scientists to call it a large unbridged gap. So to me, that says a lot right there. But it does have a lot to do with the mode of locomotion between humans and the Australopithecines. They most likely had a quadrupedal knuckle walking type of locomotion, as well as tree climbing. So ecologically, the Australopithecines were certainly much more in the ape category than in the human category. It has to do with the ability of human beings to run, and many features of our rib cage and our legs and our pelvis that allow us to run. Australopithecines were not able to run. Has to do with our arms. Australopithecines had much longer arms, which show that they were probably suited for climbing in trees, whereas human beings have arms that are suited for, using our opposable thumbs to build things. Very different arms. Has to do with our skull size and shape. Australopithecines had a much more prognathic face where the jaw jutted out compared to modern humans, as well as a much smaller brain size. Their brain size is essentially the size of a chimpanzee, as opposed to modern humans, which have a much larger brain and also a larger frontal lobe, which is not seen in Australopithecines. So, that's just a few of the many anatomical differences. There are others, but yeah, that's sort of I guess, an important list there.
Yeah. So large is fairly large then.
I would say so.
I think I might know where this question's going. Do you think the hominin fossils show a bottleneck of a pair of people some hundreds of thousands of years ago?
I don't think we have enough resolution in the fossil record to say that one way or the other. And I'm sure that that's referring to kind of like a Noah's flood kind of view, or maybe like a Adam and Eve kind of view. We just don't have enough specimens to be able to say that. I mean, I think we certainly can't rule that out, but we don't have enough resolution in the fossil record to be able to say that, to address that one way or the other.
Okay. Next question. Is there a discontinuity in cultural artifacts? And are the timescales consistent with the abrupt appearance of humans?
That's a very interesting question. So there is an abrupt appearance of cultural artifacts. I didn't get into this in my talk because I just didn't want to, it's just a lot. But around, it depends on who you ask, maybe somewhere around 50 to 100,000 years ago, there is what many archaeologists call a culture explosion, where we see an explosion of art and creativity and religious-like behavior. And people have said that this is sort of like the advent of modern human type creative expression, religious behavior, and language. Okay. So does it go back further than that? Well, I don't know. Maybe. People often say that the absence of evidence isn't evidence of absence. So it's hard to say, especially when we're dealing with this very sparse archaeological record. At the same time, there is certainly an archaeology explosion around 50 to 100,000 years ago of human-like creativity and tools and art and that sort of thing. So the answer to the question, does it correlate with the abrupt appearance of the Homo body plan? The answer to that is actually no. It actually does not correlate with that. The Homo body plan appears around 2 million years ago, and this abrupt appearance in the archaeology record is about 100,000 years ago. What does that mean? I'm not here to have all the answers today. There's a lot of ways, I think, to look at that from an ID, or I am a Christian, so I look at this from a Christian perspective as well. But I'm just telling you that they don't correlate. So we can make of that what we do, but that is an interesting question.
Okay, can I draw it all together, perhaps with this question, and I'll perhaps David and Alistair will join in the discussion. But this question is this: where do you draw the line personally in the fossil record? Where do you draw the line between what you consider to be reasonably certain based on the fossil record, and where the other side of that line then becomes mere speculation based on perhaps a prior view?
No, great question. By the way, these are all really good questions and tough questions too. I like them. So for me personally, I like to take the fossil record at face value. Okay. So if the fossil record shows the abrupt appearance of a new form without clear evolutionary precursors, then I like to take that at face value. I like to say this is what the data shows, and the data is not showing an evolutionary history. Evolutionists love to sort of not take the fossil record at face value. And time after time again, we see throughout the fossil record the abrupt appearance of major groups of organisms. It's not just the genus Homo. We see these explosions of new types of organisms with regards to the origin of mammals, the origin of birds, the origin of angiosperms, the origin of dinosaurs, the origin of plants, the origin of marine reptiles, the origin of in the Cambrian explosion, the Great Ordovician Marine Biodiversity Event, which I know you had Gunter Beckley on your webinar. He probably spoke about many of these other explosions of organisms in the fossil record. What evolutionists will do is they will say, well, yes, there is this abrupt appearance of major new types of organisms very quickly, very rapidly, geologically speaking, without clear evolutionary precursors. But we're going to assume that there's a lot of other species that existed that showed this evolutionary sort of build up to these new types of organisms, this evolutionary ancestry. We just don't have any fossil evidence for that. For me, I like to draw the line at what we find in the fossil record, okay? So if we're finding fossils and they tell us something about what those organisms are, then that's great. We've got evidence. What I don't like to do is to invent these ghost lineages or to invent evolutionary ancestors for which we have no fossil evidence. I'm not saying that ghost lineages are always wrong. I'm not saying that we can't extend fossil ranges when we find, but I want to do that when we find the evidence. Okay, and I'm willing to do it when we find the evidence. That's fine. But until we do that, until we find that evidence, I don't think it's right to always assume that there are fossils that are going to fit our evolutionary narrative. I mean, in the Cambrian explosion, you have evolutionary scientists who will invent ghost lineages of up to 80 million years in length. Steve Meyer talks about this in his book, Darwin's Doubt. Inventing ghost lineages to help the fossil record fit your evolutionary narrative. Maybe those fossil histories do go back for 80 million years further than what we actually see in the fossil that we've discovered. Maybe they do. But until we find evidence for it, if your only reason for inventing these fossils that you claim existed, but we have no evidence for, if your only reason for doing that is your evolutionary model, then I'm sorry, but that's not enough for me. I want to base my views upon the fossils that actually exist. And so that's kind of where I would draw the line.
Okay. Another question that's come in is this, and I quote, supposedly humans arrived on the scene after dinosaurs died out, but in 2005, Mary Schweitzer of North Carolina State found collagen and organic matter in dinosaur bones. How does it fit your timescale?
Well, look, the purpose of my talk today is to challenge the evolutionary view of human origins, okay? And that is the purpose of my talk, to sort of take the evolutionary view on its own terms. If they're claiming that these are the ages of these fossils and they're claiming that, you know, this is what happened, does the fossil evidence support their view? And so the purpose of my talk today is to challenge a Darwinian evolutionary view. It's not to get into questions of the age of the earth or the age of the fossils. I personally am an old earther. I do believe, based upon radiometric dating, that I do accept that radiometric dating usually works and it shows you something, but I'm not here to, that's not really my point. If you happen to be a young earther and you disagree with the ages, okay, fine. Like, I'm not here to really debate that or talk about that. But what I would like to do is to say that I think we all can agree. Well, maybe not. Maybe we all don't agree. That's fine. But at least for those of the folks who do take a more young Earth view, would probably agree with me that the point of my talk, that the fossil evidence does not support the evolutionary narrative. They would agree with that main point. So as far as these claims about soft tissue being found in dinosaurs, and maybe those, I've heard this claim before. The idea is that maybe those bones are not really that old. That's interesting. You know, I don't know. I don't know what the answer is. I don't have a problem saying that. Maybe they really are. I mean, I believe that radiometric dating shows the bones are old. So does that mean that maybe DNA lasts a lot longer than we really think it does? Maybe it does. I don't know. I'm not an expert in this area of soft tissue. I do think that the radiometric dating evidence is strong for old ages of these fossils, but you know, I hold all the stuff tentatively. So you tell me. I don't know. This is not my field, soft tissue data. I'm not here arguing about this stuff today. I'm here to talk about the evolutionary narrative.
Can I ask you this? It's a question we've asked some of the other speakers. What's your experience been with some of the paleontologists and others when you discuss these matters with them? Are they open and accepting of the issues and problems that you have highlighted tonight in private, more so than they are in public? You quoted the ones, I can't remember the name now, you quoted someone who gave evidence saying that it was beyond doubt. Are there two stories being told, the private and the public here, or not?
I think what I would say is that there are two stories being told. One is the public story. I don't want to call the other one private, but I want to call it the technical literature story, okay? Which basically nobody reads except for, insiders in the field. There are definitely two stories being told. When Professor Wetherington testified before the State Board of Education in Texas, he was telling a story that is very different from what you read in the technical literature. And so, yeah, when I talk to, evolutionary scientists, they do tend to be a little bit more candid about the problems one-on-one. But I think that, you don't have to talk to them privately to see that. You can see that in their writings that are written to the technical literature. It's a lot harder in the technical literature to say, there's a nice unbroken chain of fossils documenting the evolution of human if that chain doesn't exist, because you're going to have peer reviewers that are going to say, no, take that out. So I think what Professor Wetherington said, again, I'm sure he believed what he said, but he would be hard pressed to get that published in the journal Nature or the journal Science or something like that. So yeah, there are two stories being told. I agree with that. There's a private one, there's a public one, and then there's the technical one. It's still public in the sense that anybody can pay money to buy those papers and download them if that's what they want to do. So in a sense, it's not private. It's just a lot harder to get that story.
That's great. Casey, my thanks again for a fantastic talk, and really enjoyed the talk and the Q&A. So thank you ever so much for that. I will hand you back now to David Galloway.
Thank you so much. It's been a lot of fun. Really appreciate the great questions, you guys.
Brilliant. Thanks, David, and thanks, Casey, for a fascinating conversation, really. And the presentation was just outstanding. It's good just to remind people, I think, to remember to check out our YouTube channel for previous recordings. And make sure, too, that you visit the website. Make sure you're signed up to remain up to date with future events. And let me just say that, that next month, I'm delighted to say that we've got Michael Denton coming to be our speaker on a webinar. Michael Denton is well known, of course, as someone who has written a number of books, not the least of which being his Evolution, A Theory in Crisis, and then a follow-up to that, which came along more recently, still A Theory in Crisis. And then there's been a whole series of books on the so-called Privileged Species series, and some of the titles are there on the screen at the moment. And then more recently, he's written this remarkable book, The Miracle of the Cell. Michael lives in Perth in Australia, and he will be with us on the 17th of May. And his topic is going to be entitled A Primal Blueprint. So that's one not to be missed. I might just say very briefly, just before we conclude, that Alistair Noble, who was featured earlier on this, and I have written a little book called Follow the Science, which has literally just appeared. It's not quite appeared in ebook format yet, but this is a book which really just picks up some of the themes that you've heard tonight. Indeed, some of the themes that you've possibly heard in previous webinars as well. How the science sometimes seems settled, and yet when you get into the evidence, that sense of consensus is rather shaky, to say the least. And so we wrote this book, Follow the Science, really the theme and the title spinning out of the notion that came from so many politicians and policymakers who were prepared to say, we're following the science. And then it became increasingly clear that the science wasn't nearly so settled as some people like to imagine. And I think that's come through in our discussion this evening. Actually, just in that regard, we have an online book event, which is being hosted by a local bookstore here in the west of Scotland. And that's going to be on Friday evening at 8 o'clock. And so it may be that some of you would like to tune into that. The special offer is that the book is going to be at reduced rate for that particular event. So I think with that, we can conclude. And let me just say once again, Casey, thank you so much for a fascinating presentation and discussion. Thanks to David for handling the Q&A in his usual masterful style. And we look forward to seeing everyone again on the 17th of May. So make that known and make sure that you bookmark the date for the session on the primal blueprint with Mike Denton. We'll see you then. Goodbye for now.